Welcome, everyone. First, I'd like to introduce Mr. Stephen Catt, or Dr. Stephen Catt, excuse me, who has been kind of leading this advanced manufacturing project to kind of share a little bit about what makes this all possible.
Thank you, Patrick, and thank you all for joining us. I thank our guests. I thank our speakers, especially thank everybody who's joining us today. This is an important topic that began probably 3 years ago with this particular grant from the National Science Foundation to explore how advanced manufacturing can better serve tribal colleges and tribal communities. We've been, researching and doing a lot of things over the last number of years. One of the things we've done in about 2 years ago or so was we hosted a number of stakeholder meetings, of which Sarah, Craig, and Stan, a lot of different people participated in from a variety of different perspectives and tribal perspectives as well. And these webinars, this is the first of a set of three. These webinars are a culmination of many of things that we learned. So bringing these speakers together, having these conversations helps progress us in that journey of how advanced manufacturing and these emerging technologies can help us grow and serve tribal communities in a much better and effective way. So thank you to the National Science Foundation for helping fund this and helping to lead. Thank you to AHEC, the American Higher Ed Education Consortium, for doing all of these things and helping us do this. And I've been acting as the project manager for this particular grant for the past year or so. So I'm very pleased that it's all coming together. And again, thank you all for joining us. And you'll hear from me sporadically throughout this webinar. Thanks.
Oh. So, introduce today's conversation. In the first in this series, we're asking, what is advanced manufacturing? In a nutshell, it's a dynamic field that merges cutting edge technologies with traditional craftsmanship. In our rapidly evolving world, where innovation drives progress, understanding advanced manufacturing is crucial. Today, we're going to have a conversation with some amazing panelists, kind of at first taking a moon's eye view of advanced manufacturing, exploring its applications and uncovering the potential it holds for tribal economic growth, tribal colleges, communities, and individuals. When you think of advanced manufacturing, what comes to mind? Maybe it's clean energy. Whoops. Maybe it's clean energy technologies. Perhaps it's 3D printing. Maybe you're thinking about robotics. Or maybe it's using the latest advancements in artificial intelligence and machine learning. Well, today we're going to have a great conversation with some leading industry experts and really dig into the question, what is advanced manufacturing? And most importantly, we're contextualizing this question specific to Indian country and really thinking about how this can benefit tribal people, with a capital P, minimizing and reducing impacts to the environment and enhancing tribal cultures to advance self-determination. And without further ado, I'd like to introduce Dr. Stan Atsidi and Andrew Custis from Sandia Labs.
Thank you, Patrick. I really appreciate it. I was looking forward to this meeting all this week and just wanted to again welcome everyone. And I was thinking about this whole topic. My last name, Atskide. In my professional name, I tell people it's at the city. Take the out at city, but in my language, it means atskide, which means literally pounding on something like a hammer, but it implies silversmith. So what it means, my name has advanced manufacturing written all over it. I was talking with Andrew this morning. The technical term is thermal mechanical processing to make artistic creation of a variety of forms using silver and turquoise. Some of you wear them. So that's advanced manufacturing. It's in the name. My first name, just a generic name. I wish my mother gave me a different name, like native, whatever, but Stan, it just goes by Stan. So I'm a senior scientist at Sandia Labs, 30 years. The photo that was shown earlier is my high school photo. So it just kind of spans, it's a bookend that's happening here. So, and 30 years, I'm an electrical engineer, PhD, Virginia Tech. I have power systems, power electronics, and some electrochemistry background. And but we do in the projects of batteries and power electronics, we run into advanced manufacturing all the time. So I'm going to be tag teaming today with my colleague Andrew Custis, and he'll take this on. But Andrew, we'll hold off on that for a little bit. But I'm always about words. I'm always about definitions. We as scientists are always about definition. We ask the question, what is that? So I was looking at the word manufacturer. What is that? And when you break it down, manus, which is hand, Allah, hand. And then the other part of that, manufacturer, fatura, which means to do, to make. So in simplest term, it's something made by hand. So in this case, in my language, we say khatishi Allah be'yagi. Khatishi means something. Allah means with hands is made. That's what the basic core of the word manufacturing mean. So in that case, well, what is advanced manufacturing? Well, advanced manufacturing, simply put, is something made by a machine. Now it's getting away from the hand. And then, but I want to preface this and say the hands are still there. The hands are, you cannot take the hand away. Yes, there's artificial intelligence. You cannot mimic. We can mimic something that is repetitive, but you cannot mimic emotions. There's something about the human mind we cannot mimic, but we can mimic up to a certain point, something that is repetitive. Yes, we can have robotics, we can have things that we can process to do that, but after that, it goes beyond us. We can't mimic. We can only mimic up to a certain point. So advanced manufacturing, something made by machine and hands through automation, additive manufacturing, and robotics. Okay, coming back to the native people. This native people through survival has made many things by hand for survival. Let me give you an example. The Inuit tribe, through the process of squinting because of the sunlight and snow, they were able to develop a manufactured part out of wood, bone, antler, whatever. And they built this tiny slit, which mimics the squinting, which reduces the ultraviolet rays that get into the eyes. And guess what? That's those goggles are predecessor to today's sunglasses. There you go. So sunglasses is to reduce the ultraviolet rays to get into the eyes. There you go. Other examples are, again, the Inuit tribe, developing narrow boats covered by sealskin and animal hides, which we call kayaks today. And today, they're utilizing, modern materials like plastic and carbon fiber, but still the design of that the stability of that design still remains from the Inuit tribe. And now it's just made with different materials, but the design is essentially the same. That's made by hand. It's a human in the loop. The Navajogan in a circular manner using wood and structure to increase the thermal property of that. They know that the the heat propagates in a spherical manner. So there you go, you optimize that in a circular pattern with an R factor of dirt around it, so you can have like roughly 60 degrees Fahrenheit throughout the year. I mean, that's again some manufacturing and hands. So with the native point of view, it's written all over the place. It's all over the map. So I thought I get back into the definition: something made by hand. In advanced manufacturing, we're starting to introduce machine, but the hand doesn't go away. So let me hand it over to Andrew, and I'm going to have Andrew define how Sandia defines advanced manufacturing, why we're interested in advanced manufacturing, and he'll give a few examples. And then once Andrew's done, I'm going to go ahead and sum it up, and that will be our part, and we'll take questions from here on out. Andrew?
Great, thank you, Stan. I want to thank the hosts and the organizers for this opportunity to present on some of our definitions of advanced manufacturing. I think Stan did a great job of a nice introduction, describing his really exceptional career. Just a quick introduction to myself. My name is Andrew Custis, and I've been at Sandia going on about 8 years now, following graduate school, where I got a PhD in materials engineering. And I currently work in the advanced metal processing department at Sandia, where our emphasis is primarily on advanced manufacturing of metals and alloys. We're a little bit more heavily weighted on 3D printing, and so I will describe some examples of that in this talk. Stan and I also thought it would be kind of nice to provide a quick overview of Sandia National Labs, just so the audience is aware of us as an organization. And you can kind of see some of the historical context here, where we were derived out of the Los Alamos, which is a sort of a companion laboratory in Los Alamos, New Mexico. And we were created out of their Z division and focus on development of non-nuclear components. And so Sandia National Laboratory was established in the late 40s, and we have a site both in Albuquerque, New Mexico, as well as Livermore, California. Those are sort of our two primary sites. I know there's a few other sites as well. And then over the years, we've had a few different sort of organizations that have overseen our operation. Currently, it's with Honeywell. And one of the things I want to highlight on this slide is a letter from Harry Truman to the then president of AT&T. And the highlighted statement here that I want to take a little bit out of that, there's a statement that says exceptional service in the national interest. And that's really kind of Sandia's calling card, if you will, to address various national problems and provide solutions based on our subject matter expertise. Now, since those kind of earlier days of our development, which came out of the Manhattan Project, Sandia has evolved into what we refer to now as a multi-mission laboratory. And this graphic illustrates sort of our 5 primary portfolios of areas that we contribute to. And so, again, kind of emphasizing the fact that this is an interdisciplinary laboratory, and we're addressing various types of national problems, taking a multi-mission approach. These statistics are probably not up to date, but this gives a rough idea of the employee count. So a majority of our folks are in Albuquerque, New Mexico, with another big portion in Livermore, California site. But you know, if there's any opportunities, I encourage folks to take a look at the lab and see what opportunities may exist in these different investment strategies. And then finally, as a way of closing out the introduction portion here, to give a few sort of tangible examples of how we're providing exceptional service in the national interest beyond just kind of as a weapons laboratory, I want to highlight just a couple of examples. So shown here, clean rooms. Sandia had a very big part in development of clean rooms, which are pretty ubiquitous to a variety of chemical processes and other types of advanced manufacturing methods. For instance, you could think about the semiconductor industries as another example, where clean rooms and other technologies like this are really benefited from the development of those controlled environments. Another area that we have a big emphasis in is in supercomputing. So we use various types of advanced supercomputers to accelerate development of manufacturing processes, advanced materials, and other types of problems. And so we have these very large, really capable computers that we're now integrating with artificial intelligence and machine learning and so forth. And then as a final example here, I just want to show that these are some images depicting a couple of disasters that have happened over the years. And these particular cases are other examples where Sandia is called upon to deliver subject matter expertise again, addressing these problems and providing a solution to help us overcome some of those disasters. Now, today's focus is on advanced manufacturing. So I'd like to define that for us a little bit from Sandia's perspective and also describe some of our interests. But if you even just did a kind of a quick Google search of advanced manufacturing, you actually might see a few different definitions depending on which government organization you're looking at and which industry member might be defining it. And so our definition that we use most often is captured here, where we define advanced manufacturing as the entire suite of capabilities, digital tools, digital information systems, materials, processes, and advanced technologies, and talent needed for rapid system design, development, qualification, and production. So Sandia sort of takes the approach of not just the technologies that are being accelerated and developed to ultimately improve upon manufacturing from the perspective of the state of the art, but also asking the question of what sort of talent do we need in order to facilitate successful integration of advanced tools? You know, what kind of engineers do we need to have, scientists, business folks, program leaders, and so on, to ultimately achieve this goal. So it's sort of a full value stream, I guess, if that's the right way of capturing it from our perspective. Now, in particular, from some of our technical interests, you know, we have what I would say is generally three distinct categories or areas where we are looking at trying to take advantage of advanced manufacturing. The first is to reduce risk and accelerate component development, and this can be for a number of reasons. For example, to try to simplify assembly processes and also accelerate processing opportunities for different types of technologies. One of the earliest ways that we've explored advanced manufacturing, I think this is also pretty common more generally in the community, but to use advanced manufacturing methods to create various types of prototypes that we can then use in a testing apparatus to evaluate its performance. There's also interest for developing advanced tooling and fixturings. And then another key area that we have been focused on with regard to advanced manufacturing is opportunities to replace lost manufacturing capabilities. So over the years, we may have updated some of these capabilities, and advanced manufacturing is really doing a nice job of capturing some of that. In addition to this, we also look at the value added of advanced manufacturing, both from the perspective of developing advanced components from a design perspective, perhaps achieving geometries that you can't achieve with non-advanced manufacturing methods or conventional approaches, and then also engineered materials where we can try to go beyond the idea of just manufacturing a single monolithic component and asking the question of, can you have sort of graded materials or say multi-material architectures in simple geometries? And we're continually growing this across Sandia. A few examples are shown here, highlighting instances where we've successfully implemented advanced manufacturing tools. For example, our Sandia telescope, where we've used 3D printing and other techniques to advance the design and improve the performance of the telescope. Another example is printed electronics, so using 3D printing to create advanced circuitry, and then also evaluating components even in a sort of mock-up of a full-scale weapon. And so those are just a few key examples here. And to, I think, drive it home as a final set of examples, in particular, these are representative of the group that I work at the lab, the Advanced Metal Processing Department, where we, as I mentioned earlier, have a big emphasis on 3D printing of metals and alloys. And these are a collection of images showing our workhorse 3D printing technologies. So the newest member of the family is this large format 3D printing device where we have a robotic cell that's used to create three-dimensional parts. And I guess maybe take a quick step back. When I'm talking about 3D printing, I'm talking about the opportunities to create near-net shaped geometries in a layer by layer fashion. So you'll deposit a single layer, and then you'll offset your manufacturing tool some distance and deposit another layer, and do that iteratively until you create a three-dimensional part following a CAD geometry. That's applied to all three of these manufacturing methods. But showing an example here of the large format where we're printing using wire feedstock, our Thunderbird mascot, which is representative of Sandia, creating large geometries that could be used in different types of aerospace applications. Powder bed fusion, which is another method in which you deposit layer by layer, but this uses powder feedstock, so you're laying layers of powder and creating net-shaped geometries. And the big push for this type of technology for us is creating really advanced designs. So what I'm showing here is an example of an aerofoil where we actually saved about 90% of the weight by creating what's called a lattice structure. So it's kind of a porous type structure while retaining good mechanical properties. And that's only enabled by this type of manufacturing method. And you can see from the artifact on the lower left here that you can print some very, very fine features, you know, single millimeter geometries, which are pretty unique for 3D printing. And then finally, to wrap it up, my personal favorite method, which is called directed energy deposition. I have a video for this one. It's a method in which you have powder that's fluidized and you consolidate that locally layer by layer. The really neat thing about this, coming from a metallurgy perspective, is that you can create materials that have multiple compositions. And so I'm showing an example of a ring here where the inside of the material is actually magnetic and the outside is non-magnetic but very corrosion resistant. So you can envision different combinations like that. And then another case where we printed a housing, and inside this housing is sort of a pyramidal shaped copper. And so you could think about this from a perspective of heat transfer, which I know Stan had mentioned about that earlier during the chat today. So hopefully this provides an example of some of the areas where we're trying to advance metal processing from the perspective of 3D printing. And I think with that, I'll turn it back over to Stan for some concluding remarks.
Excellent. Thank you, Andrew. Thank you for that. As Andrew said, the definition is all over the place. They can be very vague to is very specific from Sandia's point of view. It comes down to talent and capability, just like Andrew said, talent and capability. And that's where I think the TCUs can thrive in the area of talent and applying some of the capabilities you have on various sites of TCUs. So that pretty much ends our time, and we look forward to questions you may have at the end of the next two presentations.
Oh, yes, Dr. Atsidi and Andrew, thank you for that very informative presentation. Up next, I'd like to introduce Sarah Bourvois from the New Collar Network. And Sarah, what is advanced manufacturing? And you're on mute.
Can you hear me now? Good. Well, thank you so much for inviting me. As is obvious from my name, I come from a French family, and the early settlers in my family, a very, very long time ago in the Northeast, intermarried with the Iroquois. And so I spent a lot of time both with the Narragansetts, who were cousins, and the Iroquois. And so I've always had a real interest in our native peoples in our country through my family. And I spent my career in laser materials processing. I am a fellow of the Laser Institute of America and owned the company that invented and manufactured the laser for LASIK eye surgery, as well as invented the process for manufacturing laser micromachining, actually, nitinol, which is a shape memory alloy that is used for coronary stents. We built 120,000 coronary stents a month for Johnson & Johnson and other medical device companies. And so I come from high volume manufacturing. And even though inventing the lasers required PhDs, I was always really interested in the training that we could provide for our people who were on the factory floor, because it's those people who actually made our parts. It was really those people who made our products. It was not the PhDs. And it was very clear to me as the years went by that we in the school systems were not giving as much time and thought to those training programs. We were encouraging everyone to go to college, which is a good thing. All of us have lots of degrees, and I appreciate that. But it's not for everyone. And there are often mitigating circumstances where college isn't an option for someone, or maybe they have no interest in studying all the things that it takes. And so when I sold Potomac Photonics, I went to consult for the Media Lab at MIT, and I was in Neil Gershenfeld's lab in the Center for Bits and Atoms. And it was Neil who had generated this concept of fab labs. And fab labs are digital fabrication laboratories where he believes anybody can make almost anything. Maybe not every single thing, but almost anything. And I started to look at this as a really great methodology using digital fabrication tools where you can make almost everything, and combining that with project-based learning. And to me, advanced manufacturing is something that is a whole different image than we have of what manufacturing is like. And I see Tony is on from SME, and SME maybe 5 or 6 years ago did a study of what parents thought of manufacturing as a career path. And interestingly, the parents had a more negative view of manufacturing than the students, and they saw manufacturing as something that was dirty and dangerous and without a lot of career advancement. And what has happened over the years is that manufacturing, advanced manufacturing at least, which really everything is now. Think of your UPS man, he carries around a computer. And as I looked at that, I thought these kinds of skills are now, these blue collar jobs with these kinds of skills are now new collar jobs, which is a term coined by Ginny Rometty at IBM. And she was the former CEO, and she wrote a letter when Mr. Trump was elected and said, we're so thankful you want to bring back manufacturing, but we don't want those old jobs. We don't want those dangerous, dirty jobs. We want new collar jobs. And I thought that so embodied what has happened in manufacturing over the years as I've been involved since 86, 1986, not 1886, but 1986. And I've seen it all become much more digital, much more open to people. And when I think about those jobs on the factory floor, and I look at a place like Los Alamos that we're very close to, I'm in Santa Fe, New Mexico. There are so many of those jobs that are good jobs, they're well-paying jobs, and they often don't require a college degree. So we developed a digital badge program so that it has far more flexibility for today's people who may have child responsibilities or may have transportation issues. And in a rural community, that's definitely an issue. Our badges were developed in collaboration with America Makes, the National 3D Printing Institute, and later were approved by the US Department of Labor as the basis of a 3D printing registered apprenticeship, which was, I believe, the first in the country. And what I see there is how for many of our people in our Native communities, but also in the world today, young people have a very different view of a career than when I went to school. That this gives people a way to maybe get into something and see if they like it, and that they're much more open to switching careers than we ever were. And it has really opened up, I think, opportunities by giving these alternatives. The Harvard continuing education program now issues more certificates than Harvard grants degrees. And I think that says a lot about how the world is changing. And they're even thinking of taking the Harvard MBA and turning it into a certificate program where you have certificates that you can then stack, if you choose to, into a degree program, kind of a progressive kind of method there. With the apprenticeship program, we saw that there was real need for kind of a pre-apprenticeship to get people getting to know what it was like to work with these new tools. My lab, I have an MIT Fab Lab in Santa Fe, and we have 3D printing, laser machining, CNC machining, CAD design, all of the tools you need to make almost anything. And we developed a pre-apprenticeship program with the Santa Fe Indian School. And it was very gratifying. We did a program a few years ago, and one of the girls was asked how, how did the program help you and what did you think of it? And she said something that was so interesting to me. She said, I knew that college probably wasn't in the cards for me. She had a lot of family responsibilities in her pueblo. And she said, but I took this course and I realized I could entrepreneur my way through life. And I'd never heard entrepreneur used as a verb, but I thought she really captured, what the program had done for her. And this is a ring that was designed by one of our students, not at the Indian school, an adult woman who didn't graduate high school. And it is the Taos Pueblo. And she learned to design in CAD. We 3D print in a resin 3D printer the molds for her. And then her husband has the casting company here in Santa Fe, and then she has it cast in Sterling. And what she says is that advanced manufacturing opened up the possibilities for her business, because now instead of sitting there by hand carving, she can design in CAD. It's still her ideas. It's still her own creativity that's coming out, but it speeds up her process and allows her to have more time to do sales. UNM is working with some of the pueblos more in the central part of the state, and they are doing clay printing, and they are printing pottery. And very interestingly, they said it's the women potters who are latching onto it because they have so many childcare responsibilities and so many home responsibilities that they really value the way it has afforded them more time with their families. And so I think not only does advanced manufacturing, when I started, it was in factories and it was very sophisticated. And it has really changed and become far more accessible to everyday people. And I'm working now with a group called Fab AI, and we are taking 3D printing. We've developed a large language model, so a huge data set with billions and billions of data points, so that we can then have a mentor on your shoulder. And it's amazing how these tools can be used not just to get good jobs at places like Sandia and Los Alamos, but also to create entrepreneurship opportunities for our people, and expand the way that we can earn a decent living and support our families. And that's really what our program is passionate about. So thank you for having me.
All right, but oh, Sarah, thank you. And up next, from the National Coalition of Advanced Technology Centers, I'd like to introduce Mr. Craig McAtee.
Well, good afternoon, Patrick. It's so good to be with you from Cleveland, Ohio, today. And I want to give you a quick overview of myself and then a brief snapshot of what the National Coalition of Advanced Technology Centers is all about in the nation. And then I really want to quickly drill down into how we've been working with Stephen and the team on the tribal communities understanding and learning, and want to dive deeper into that. In my Jamboard post today, I just want to continue to support and learn how we can do more with the tribal communities in the nation as a national organization. But for me, I always had the artistic flair, if you will. I drew cartoons in third grade, and I got recognized, and my teacher said, hey, every month could you draw a cartoon for the calendar and put it on the door? And it's like, wow, I can do this. And then fast forward to the junior high and high school years, I remember I just developed a real talent naturally, as well as being educated in drafting, and then moved into architecture. And by the time I graduated high school, I went to West Virginia University the first year and wanted to be an architect. And within that first year, I really quickly discovered that I hit the math wall, and that was, calculus and advanced algebra and those kind of math formulas that were on a whiteboard, and I had no idea how to apply them in the real world. I just had to study them and pass them on a test. Sound familiar? So I went to Cleveland after that and enrolled in a community college and got my 2-year degree while I tried to figure out what I wanted to do, and found my way to Kent State University, where they had a non-ABET accredited engineering program for industrial engineers. And I got into that, and lo and behold, I was making things. I was doing foundry work. I was doing cabinetry work. I was doing things with blacksmithing. I was making things out of metal, and learning how to use an IBM computer at the same time, a 360 with cards. Anyhow, I learned all these things in an applied way. And lo and behold, a company in Cleveland, who is an international manufacturing company by the name of Swagelok, picked me up as a young engineer in the 1970s, and got me on the shop floor to do critical thinking and problem solving on their manufacturing floor. I had a lot to learn, but the cool thing about the Kent State degree in engineering was that I was able to apply and critically think through what was going on that shop floor much better than I would have if I would have had a custom, regular old theoretical engineering degree from, say, Purdue. Now, I'm not knocking Purdue or any other great colleges that produce engineers, but what I learned was hands-on. And so I guess that carries into what I do now. So the first 25 years of my career, I spent doing those things. I'm a recovering engineer. In the 21st century, I jumped off that bandwagon and joined the same community college I got my degree from to run their Advanced Technology Center, which was all focused on manufacturing and applied technologies, my sweet spot. And we grew that over 7 years. And during that time, I got involved with the National Coalition of Advanced Technology Centers. And I want to give you a quick snapshot of what that is. And I'm only going to share a few slides. But can you see this? It's just a quick overview of our 4 pillars. Our 4 pillars at the community college level across the nation, with NCATC, is the future of work. Now, we were formed in 1988 by 2 companies, IBM and Lucent Technologies, and they didn't know where they were going to get their workforce. And they came to 700 community colleges in the nation and said, can you help us figure out how to train the people that actually became those that rolled out the backbone of the internet for those companies as they move forward? And so we've always been focused in this organization, the NCATC, on the future of work. And we've been very heavily involved for the last decade in Industry 4.0, 5.0, X.0, and that's smart manufacturing and smart automation. Now, Patrick didn't ask me what I believed advanced manufacturing is, because I think he knew what I was going to say. And to me, it's everything we're going to talk about and have talked about today with digital infrastructure, everything connected to the internet or digitally controlled. To me, that's advanced manufacturing. And so our second pillar is all about how do we get more students in the pipeline to get work-based learning? How do we get them to learn like I learned at Kent State, by doing, applying their knowledge as they're learning how it comes to be? So internships, apprenticeships. Sarah mentioned the 3D additive apprenticeship. We worked very closely with America Makes during those times as well, and gave some good input on those things. And SME as well, on certifications. We believe in those things. And that leads to the third pillar of our organization, is all about competency-based education, applied skills and knowledge. And then when we can connect that with industry recognized credentials and certifications, and that maps to these shorter term certificates that Sarah mentioned, we're all in. That really is where we want education to go. And we promote that everywhere we go as well across the nation. Now, the last pillar wraps around the other 3 all the time. And that's all about adult learning opportunities with access, diversity, equity, inclusion, and belonging wrapped in that way we deliver that to the underserved and underrepresented populations. So I want to make sure you see what we stand up on, those 4 pillars every day of what we do with our community colleges. This is a quick snapshot of our organization today. We went from 7 in 1988 to over 175 community and technical colleges in the nation that are now members of our network. But even equally greater than those 175 coming together from Hawaii to Maine to Florida are the 48 corporate strategic partners. Now, these are some big names and there's some smaller names, but a lot of these folks represent things that you've learned or will learn on in the labs, whether it's Mastercam and Autodesk in the design aspects, or the robotics with Fanuc or Universal or Festo. All of these companies represent hands-on experiential learning, either online or in the labs in person. So we partner, and these are members of our organization as well. And you can find these on our website. I'll put that in the chat later if you want to look a little deeper. But we also partner with 8 of the Department of Defense Manufacturing Innovation Institutes, Manufacturing USA. And Sarah mentioned America Makes. They're the very first one that was stood up in Youngstown, Ohio, about 11 years ago on additive manufacturing. But every one of these that's listed on this map that you see that has the red arrow above them, we're very much involved with their workforce and education councils. And we actually sit on 4 or 5 of those to help them understand what's going on in the community college network in their field, whether it's composites at IACME down in Tennessee or over in the West Coast, and I'll talk more about NextFlex in a minute, flexible electronics, or robotics in PA, et cetera. We're very much involved in these 8 Department of Defense funded manufacturing institutes. So last but not least, this is a quick snapshot of what I mean by smart manufacturing or Industry 4.0. And you've already heard the folks before me, Dr. Stan talked about, and Sarah, about the additive manufacturing and Internet of Things. But the cloud computing, autonomous robots, advanced materials, which is Sandia Lab all over the place, simulation, augmented reality, artificial intelligence, and big data analytics. Those are all big pieces of this system integration or digitalization, as I talked about, advanced manufacturing being digitized. And wrapped around all that, the last block on this graph is cybersecurity. And we talk about it. We do a lot of cybersecurity training, but we can never do enough, because every day you pick up the paper or you look at your app for smart news, and the bottom line is somebody's been hacked. So cybersecurity is wrapped around everything we do in this digital world, and it needs to be even more learned and understood as we move forward. We're also working very highly in the electric vehicles and semiconductors, but I'm not going to dwell on that. I just want to spend more time with you talking, and I'm going to take the screen down. But I wanted to give you that snapshot, and I'll share that with Patrick afterwards in case anybody wants to, talk more about that in the future. But really, how do the TCUs operate now? I'm just learning about that more and more over the last 3 or 4 years working with Stephen and AIHC, and I want to learn more. But I think there's a lot of things that we've had lessons learned in the community colleges that we can help leapfrog, if you will, into doing things better from the start, not working through all the muck and mire that we've worked through to get there. So that's our goal at NCATC every day, is to have people not need to reinvent any wheels that have already been invented, and that is a really big part of what we do on a daily basis. And then how do we take all the things we've done with our partners in community colleges and industry and translate that into micro manufacturing, micro factories for small rural areas, tribal areas as well, and how to leapfrog those technologies into labs and learning, whether it's online or in person, for you. And one of the examples I wanted to give you, and I've not heard this term mentioned yet, but I know Sarah's all over it. We promote for the last 20 plus years STEAM over STEM, and you've heard of science, technology, engineering, and manufacturing, and math, I should say. Math. M is the math. But we really believe all those things are important. But if you don't have the arts, which is this A in STEAM, embedded in that approach, you've lost 50% of the population that we have to work with. And that, like me, with an art bent, I learned science, engineering, math, and technology along the way. And I had a gift to understand how to take apart a clock and put it together and not have too many pieces left over. But the arts part of that is the design, the innovation, the creativity, and the entrepreneurship that we need more of. In fact, I remember a few years ago, Siemens and IBM and a few other companies, Google, I think, put out ads saying, we want the creative people. We want the STEAM-oriented people. So to me, the design and content considerations that you all are working in, that 50% of the population that thinks more with the right side of their brain than the left, we need as equal or greater, because they can then make things much better. Look at Steve Jobs with Apple, right? He created things we didn't even know we needed, and now we can't live without them. So the NextFlex organization on the West Coast that I mentioned, they're focused on flexible electronics. And one of our new partners, probably a partner with Sandia Labs, based on what I heard this morning or earlier today, was electronics 3D printing. One of those companies is Nano Dimensions, and they are one of our newest partners on the list of our strategic partners that I mentioned and showed you. And they are focused on flexible electronics. And a lot of you have heard the Semiconductor Chips Act that's been funded and keeps getting more funding. And it's not everywhere in the nation, but it is in Arizona, it's in New Mexico, it is, of course, in Ohio and Texas and Oregon and California and Washington State. So there's a lot of pockets of semiconductor, but those kind of technologies can really be used in that the middle of all that, whether it's microelectronics or it's maintenance on a shop floor or robotics. The core of that is what we call mechatronics. And if you've learned anything about hydraulics and pneumatic systems, mechanical systems, electrical systems, and you couple all those major systems of automation with a PLC, a programmable logic controller, which is what robots are controlled by, and a lot of other things in automation, assembly lines are controlled by. You've learned 60% of what you need in any sector, whether it's healthcare and the hospital systems or rapid transit systems, or even the grocery and fast food are being automated with robots and automation. So those things that I just talked about in mechatronics or applied mechanical electrical systems, if you can learn those, you've got the world by the tail. And that's just one thing I've learned in the last 20 years of being involved with community colleges and NCATC, learning from our partners that I mentioned in industry. And I just was at a conference with Intel, Texas Instrument, Dell, and Semiconductor Foundation in January with the AACC, which is the American Association of Community Colleges, which we're part of. And we basically asked that question, is this still valid that mechatronics is the core for learning anything in your fields that you need? And the resounding answer from all four of those major organizations was absolutely yes. So mechatronics, if you don't know much about it, please think about that. And then you can springboard. And what we're doing at NCATC is helping community colleges and small and medium-sized companies understand and demystify what smart manufacturing, automation, and Industry 4.0 is all about. And that's when you can start adding robots and cobots, collaborative robots. And then you can think about, if this watch is connected to the Internet of Things, then nothing more than that is the industrial Internet of Things, which is robots, conveyor systems, CNC machines, etc., all feeding data to a big data analytics computer and being able to be diagnosed or at least prescriptively used by the human, which is huge in this whole factor. I love what Stan said about talent and capabilities. And that's what we focus on every day. It's not just about the technology at all. It's about how to get the technology in the hands of humans and how to give them the skills, knowledge, and abilities to use those in an applied way in a job or a career, or improve their career by learning something new like AI. I was lucky enough to give a commencement speech last summer to one of our colleges in West Virginia. And throughout there, I know I mentioned AI changing everybody's world in the audience as well as on the platform, greater than the internet has in the last 2 decades. And trust me, if you can stay up with where AI is being used, and Sarah, I love the idea about the Fab AI and that mentor on your shoulder. I want to learn more about that, because that's something we want to take to our members and partner with you on as you move forward. And we promote the Fab Lab and the Makerspace in all of our community colleges greatly. So I want to make sure that we focus on that high quality, low volume manufacturing is where I think the tribal communities can really focus on those more customized manufacturing products and services that are out there in need. And the more we have quick change setups on machines of any kind, whether they're 3D printers or CNC, or I didn't mention welding. I mean, that's a huge piece of the puzzle of advanced manufacturing that continues to be in high demand. Welding and soldering and anything done with heat in metal is a huge piece of the future of work, and it will continue to be as materials continue to be needed to be joined together in a platform. So that micro factories focus on high quality, low volume is really another piece of the puzzle. I want to close on a couple points, and that is with what I've experienced in my 50 years of in the workforce and both in engineering and manufacturing, and then education and workforce development. I've learned some things that I think definitely need fixed in education. And Sarah talked about a couple of those, and that is we don't need anything in the 21st century measured in hours, even though we're saddled with that at college. 2 and 4 year colleges are still based in many ways on credit hours. And unfortunately, I could take a course on 3D additive printing, and Sarah would take the same course. She'd breeze through it because of her background and probably pass it in 3 hours. It might take me 30 to get to that same level of competence. But that's why hours-based training is not appropriate. What we need is that competency-based education, applied learning, check through the certifications and credentials that get you to that knowledge and skills abilities by the mentor or the teacher in the classroom or the lab, and says, yes, you've demonstrated you can do this, you've become proficient at it, and then at a time where you can master that is a time you can actually teach others. So to me, it's more about learning in a way of applied skills and knowledge. And we're trying to get more contextualized math and science in colleges and across the nation as well, where it's not just learning on a whiteboard math problems and formulas, but how do you apply that in the real world of thermodynamics or electronics or 3D printing or anything else that we do with math and science. We're looking for more technicians and makers in the world than we are PhDs and even engineering degreed folks, even though those are always going to be important in R&D in the world to keep up on what the future trends are. In those manufacturing innovation institutes that I talked about that are funded by DoD, all of those are funded, 95% of their money is funded for R&D, which is huge because the Boeings and the Rockwell automations and the Lockheed Martins of the world need all the help they can get to keep up with our other countries that are emerging, China and in India. But 5% of the funding that goes to that is for workforce development, and that's where we sit in and help them collaborate with the community colleges. So to me, that technician and maker level, there's a formula and a ratio that is proven that there's a 1, 2, and 7. For every one PhD out there in research and development, there are about 2 engineers that translate those research and development ideas from the labs and the whiteboards to real world experience on a shop floor to become something. But it takes 7 technicians as an average to those 2 engineers to actually implement it and make it really a real-time approach to installed, maintained, troubleshoot problems, and continue to grow that. Those are the technicians, and that's the sweet spot of community colleges, and we believe what TCUs are all about. And so the technicians and the makers are really what we focus on. I will close by saying that sustainability is huge, and I know that's a big part of the tribal communities. It should be a bigger part of what we do in the world in general. And we work very closely with SESME on the West Coast. And SESME is one of those centers for uh, Energy and Smart Manufacturing Institute is what it stands for. They're partially funded by DOE, the Energy Department, but also Department of Defense. And one of their caveats in all that they do with smart assessing small and medium and large companies for smart manufacturing implementations is the sustainability and how their supply chain really is taking care of the environment. And that is a real big piece of what we promote at NCATC as well. And one of those industry groups that I talked about, the Innovation Institutes, is in New York, and it's called Remade. And they are focused on that sustainability of recycling products once they reach the end of their life cycle. And so we partner with them as well on how to keep things very consistently thought top of mind in sustainability and care about the environment. So those are the parts of what we're all about. I hope I didn't overdo my passion about what I've learned in my 50 years of being in manufacturing. I remember being given a task in I think it was 85 or 86, to become one of our engineering technicians at my company, moving from screw machines, which are operated by cams and gears, to our new approach to CNC. And we tested Mazaks and Akumas and many other different controllers at that time. And by 1990, our company had made that transition into computer numeric controlled machines at Swagelok. And I was part of that. And now in the 21st century, I've been part of that Industry 4.0. That was 3.0, by the way, in the 80s and 90s. And now we've moved into the 21st century with 4.0. It'll never end as the transitions of digitization and AI and machine learning continue to help us do better things and not be in dirty, dangerous, and dark environments, as Sarah mentioned, in the 20th century. We're hoping that all manufacturing facilities continue to grow and learn with us. And we'd like you to be part of that as well. So I hope I didn't overdo my time, Patrick, but thank you for all of my opportunity to address this group, and I look forward to questions.
Oh. So, excuse me, let me remove some spotlights here. All right. Well, thank you, Dr. Atsedy, Andrew, Sarah, and Craig. Really informative discussion, a lot of information. And if I could just offer a bit of reflection from what I heard today, and Dr. Atsedy, for really grounding us with the language. I think one of the most critical pieces that many tribal colleges, if not all, are really focusing on is language revitalization. And it's more than just learning a language as a humanity, but to really understand as a way of thinking and to really center who we are as peoples, plural. That really reminding us that in manufacturing, this made by hand in advanced manufacturing, the hand doesn't leave. The human element is absolutely critical. And Sarah, you had really described this understanding that talent is so absolutely needed, and something that Andrew, you also had kind of highlighted as part of the description from Sandia, that talent is a critical component. And also kind of recognizing the changing landscapes, both figuratively and literally, is that, as you'd mentioned, Sarah, that there are more certificates being offered now than degrees. And thinking about tribal colleges and universities that often have emphases on things such as indigenous studies and environmental studies, that learning advanced manufacturing techniques and technician training doesn't have to override the degree. That it can be something that can be added. It could be something that could be done quickly. Craig, you had mentioned it doesn't necessarily have to be counted by hours, but as small certifications, kind of learning a technique. But most importantly, doing these things in an applied way, where you're doing them with your hands. You're learning these things that are valuable and recognizing that for those that are interested in the theory, and really doing the research and pursuing that PhD, always encouraging, especially our native communities, to really strive for that, but to also recognize that if that's not your path and that's not something you desire, there are so many more opportunities to be an engineer and especially to be a technician, and they're all needed. And lastly, to really emphasize this idea of creativity, of creating things that we're, as indigenous peoples, and all peoples indigenous to this planet, we're created in this space, and we have that gift from our Creator to be able to create these things. And so I'd like to kind of open up a conversation with our panelists, and for folks, as we're kind of doing some of these questions on, there's a second slide in the Jamboard. I'd like you, if you could, to answer, what is, after hearing these folks, what does advanced manufacturing mean to you? But I'd like to really open up this first question, and we'll start with you, Dr. Atsidi, of really thinking about knowing how technologies have had a negative impact, well, both positive and negative impact to Indian peoples in the past, as we're looking ahead and really recognizing that, we are amidst a rapidly changing climate. We have big issues in environmental contamination that we have to deal with, particularly in Indian country. What are ways that advanced manufacturing could help us leapfrog some of that language, some of our not only cultural revitalization, but our environmental mitigation and adaptation?
Yeah, good question. When I travel the country, our nation, and also around the world, particularly in our nation, I tell people, when it comes to manufacturing, of manufacturing industry, as a country, as a nation, we look either south, like to Mexico, or to other countries. And I remind people that just remember, there are nations inside. Look inside. Why not a gigafactory on the Navajo Nation? Why not an advanced manufacturing on the Lakota Nation? And by the way, my kids are Standing Rock, Lakota. So I have my wife's relatives in that area. And I think as a country, we need to look inward at times. I think there's lots of opportunities with the CHIPS Act, like you mentioned earlier. I think Greg has mentioned that. Why not? Why not a manufacturing facility? And I'm working pretty closely with Navajo Tech, also with the advanced manufacturing facility there, gaining lots of attention, and even the nation, the Navajo Nation, mimicking that process to, as a business pursuit on the Navajo Reservation for DoD, DOE.com application to provide that. So, and by the way, just a little side note on what Craig mentioned about STEAM, adding a letter. I was talking to NASA, and he said, "Hey, there was a NASA employee there, and she does the parachutes for the rockets." And she said, "I don't have a technical degree, but I designed these things, so therefore we've added the letter A." And some people say STEAM, but then my wife says, "You guys added a letter. Why not call it MEATS, which has a lot more substance to it? STEAM is just, STEAM." So interesting. So that name may change on us a little bit. So I thought that was an interesting side thing. But we have lots to offer. We weren't able to become citizens as nations until 1920s. Prior to that, some of my grandma's mothers were not citizens of the United States. In the 1930s, mid-1930s, the United States, because our people have been involved in the military pursuits, war, they felt obligated and said, okay, let's make them sovereign nations, politically sovereign nations. So the most recent thing I see with the nations, the tribes, are energy sovereignty. And they're saying, there's water, there's We have lots of photovoltaic. Why don't we become energy sovereign nations? And then why don't we become, sovereign in the area of manufacturing? Why not take that? Why not pursue that? And advanced manufacturing is so multifaceted. You can be involved in advanced manufacturing as little or as much as you want. You could be down in the nanoscale of what Andrew had pointed out at the metal structure at the atomic level, to as much as applications, to as much as policy, to as much as a political or business side of things. It's just multifaceted. So you can be as involved and as little or as much. And so I think there's a huge opportunity for the tribal nations. From let's take the sovereignty to the next level, let's train people, and let's bring advanced manufacturing to our sites, to where the nations or companies that I mentioned this to are like, they have an epiphany. They say, wow, I didn't realize there are nations on the inside. We should be looking at nations on the inside and producing advanced manufacturing capabilities on the inside. And that's based on my experience, Patrick.
Yeah. Oh, Sarah. And you're on mute.
Okay. I guess I would just add to that, we can't go back. We can't turn time back and say that technology doesn't exist. And, I guess my feeling is, particularly working with the young people at the Santa Fe Indian School, is that they're looking at it as, how can we become empowered by technology, and how can we take the technology? And of course, we're in New Mexico with the terrible tragedies that came out of Los Alamos, but again, we can't turn back the clock. How can we participate and become full participants and utilize the technologies to instead improve our situations? And so during COVID, which is how I first became involved with the Indian School, I read in the New York Times, of all places, about the terrible problems with not being able to follow CDC guidelines and wash our hands when so many of the native lands didn't have clean water. And so we developed a program with the Indian School to work on their community project of creating mobile hand washing stations. And we wanted to keep the price at a tenth of what a commercial station would cost. And the students came up with this beautiful design that incorporated kind of traditional view of design and manufacturing, where it was like a teepee, and we were able to buy a lot of the parts off the shelf at the hardware store. So we used dowels, but then they used 3D printing to make the attachments. So we had a 3D printed paper towel holder. We had a 3D printed valve that allowed the water to go from one bucket to the other. And that allowed us to do something really economical and fast, because of course people were dying. So we needed something fast. And it was really beautiful to see how these young people, and they were mostly middle and high school students, incorporated what they knew worked. The commercial hand washing stations were on wheels, and you couldn't wheel them around on the terrain. And the TP design with the dowels really allowed us to incorporate what made sense with new technology. And I think that, like I said at the beginning, we can't go back, but how can we harness those kinds of capabilities? And the young people are ready. I see it with the Indian School. They're really ready to play with these new tools.
Ooh. So I appreciate that, and I think an elder that I had known up this way always used to say, you have to look back to where you've come from. Only then will you know where you're going.
Mhm.
And so my next question that I'd kind of like to pose to the panel and Mr. McAtee, we'll start with you. And especially thank you for sharing your story of your educational journey. And hopefully today's conversation demystified this idea of like getting into advanced manufacturing doesn't require, 6 to 10 years in a graduate program to be able to enter. And if anything, it could be 6 to 10 days if done right. But I think that thinking ahead in our next web series, we'll dig into this a bit more, but that barrier to entry and how we can kind of remove that for tribal colleges and tribal communities. Realistically, what does it take to kind of get into an advanced manufacturing space, and especially if you've never done it before? What does that look like today? What is that leapfrog moment?
Well, the leapfrog moment is something we promote, we call best practices or promising practices, right? And those that are the ones, especially that have been proven out, the best practices in the nation, where industry, small, medium, and large, depending on the community, gets totally involved with the education organization, whether it's a middle school, a high school, community college, or four-year institution, whatever, doesn't matter. They are deeply and committed and passionate about being part of that solution. Now, where I come from, 25 years in engineering, manufacturing, I can say to any one of those folks, if you are not part of the solution for improving our education workforce development, you are part of the problem. So that is the leapfrog moment, is that you've got to reach out at the college level, at the high school level, whatever, and have somebody there or a team of people to be able to communicate with the organizations that are manufacturing organizations in your community and get them invited to what we talk about is replacing the 20th century advisory committees, which in my time, I saw the first year I was at Cuyahoga Community College, by the way, which is Indian, I forget what tribe, but Cuyahoga means crooked river in Cleveland, and we have a very crooked river in Cleveland. Anyhow, is to say you're not going to come and just hear the faculty talk about all their great programs and have some bacon and eggs and slap each other on the back and leave the door 90 minutes later and say, I'll see you in 6 to 12 months. No, what we've developed with National Science Foundation funding in the last 4 years, and it's going to continue, is a proven, successful, repeatable, quality-driven approach to replacing advisory committees with a business and industry leadership team. And I can share a lot more of that with you in the future, but we're now in our 4th year of doing this formally and helping mentor and coach community colleges and industries into saying, look, we need somebody to step up and be a co-leader of the advisory committee that's now going to be rebranded as a built business and industry leadership team. And you're going to set the agenda. And oh, by the way, we're going to ask, here's our what's in it for me. And it's a letter that says, we're inviting you other folks from industry to come and be part of this. And we promise we will only take 6 of your hours a year minimum, but we need you to commit to those 6. And each one of those 1-hour times is to get oriented to the build approach. The second one's a 2-hour where you list in any given program the knowledge, skills, and abilities that you believe the industry needs in your curriculum. They actually vote on it on a scale of 1 to 4, 4 being most important and 1 being not. Anything under a 2.5 average gets talked about and discussed, whether it's in or out of the curriculum. And so they have a vested interest and input on what the curriculum looks like every year. And then the next year, a 1-hour meeting is the faculty get that information, crosswalk it with the curriculum, improve the curriculum, and then report back to the industry. Here's what it looks like now. And then the 4th and final meeting of each year, and this is a minimum, is the industry saying, here's the future trends that we're going to need you to look about, whether it's AI or Internet of Things or whatever, we want you to integrate going forward, and we'll talk about it next year. But it's an annual repeat of improvement on the curriculum. But industry's got to be involved in everything you do, or you're just doing it for the same old reasons we've always done it, and that's academic, approaches which don't work anymore. So I know I went on, but there's a lot to be said
Ooh.
for that leapfrog approach. You start with a business and industry leadership team, not an advisory committee, and make it work and really make it stick with industry leading the way. And oh, by the way, in all those meetings, the faculty take notes and listen, but they do not vote and they do not have a say. Industry does. So that's the
Oh. Well, speaking of faculty, I see several TCU faculty in our audience today, and I would love to field a question from our audience if possible. For instance, I see College Muskogee Nation and Northwest Indian College representatives. Would anyone else have a question? You're welcome to unmute yourself and ask our panelists. And okay, no worries. And so, Stephen, would you like to field the last question, and then we will move to wrapping up?
Sure, I really appreciate. Oh, go ahead.
Hi, sorry, my name's Lisa Redsur. Yad Ebene, Shea Lisa Redsur Yana Shea Hashkana Zoho Nishlito Tabahan Pashishin. I am the engineering outreach coordinator for Northwest Indian College, and just wondering, because I've spoken with Stan in the past about coming and doing a series at the college, but are you all open to, you know, making a trip out or jumping on a Zoom call to talk during class time or any type of workshops? Just your thoughts on that, just because I'm gaining a lot of knowledge just from participating in this webinar series, and would love for students to be able to get the opportunity to have, you know, more in-depth questions, more in-depth conversations with you all.
Sarah?
Lisa, I'll plan to be in your neck of the woods, Northwest region, in the near future. I would let's talk, and I'd like to do an energy lecture, and let's invite the whole school.
That would be great. That's fantastic.
Okay.
Looking forward to it, Sam. Thank you.
All right.
I would add that the MIT Fab Lab Network has several meetings. I organize the North American group, and so we about every year have a meeting here in Santa Fe of our North American labs, which is really a sharing of best practices and new ideas. And then our annual meeting this year will be at the in Puebla, at the Fab Lab in Puebla, Mexico. We're very fortunate. It moves from continent to continent. So some years it's not convenient to go. Like last year it was in Bhutan, which is hard to get to. But this year it's going to be very convenient for us. And my lab does a number of workshops as well as professional development. So I'll put my email in the chat. If you reach out, I can send you information about the MIT program and then our program in New Mexico.
I also put my email in there, Lisa. Just send me an email.
Right. Oh, great question, Lisa. Great to see you. All right. So, thank you, everyone. And if you could, participants, if you could turn your cameras on just for a moment, just to thank our wonderful panelists. And you know, if you aren't able to, that's okay. But maybe use the little clapping button. But thank you all for being here today. This will be recorded, and hopefully you can share this, maybe even use this as part of your curriculum if you like. There were some really good conversations here today, and also to really reiterate that we're doing this to support tribal colleges and tribal education, and that if you have things that you want to learn next, and great question, Lisa, about how to get engaged and how to get involved, and that's going to be an ongoing part of this series. So in the future, for participants, we're going to be sharing some resources that will help you to also build these connections, build your network, and quite frankly, do our best to help you identify funding. So if you're trying to advance your programs, you'll actually be able to do that tangibly, increase capacities. And we don't want to make any promises that we can't keep, but there are some wonderful, outstanding individuals here from industry, from national laboratories, from academia, with big hearts that are doing this in the right way. And so just to wrap up, just kind of finalize some slides here.
Hey, Patrick, while you're
Yep.
doing that, can I just jump in real quick?
Sure.
So there's two other webinars. The second one will be on April 5th at the same time. The third one will be on April 12th at the same time. You'll be all receiving more information about that as we get those set up. But the second one, this first one, we wanted to really explore what advanced manufacturing is all about. Second one, we'll be talking about the economic development. We'll be exploring what micro factories are and how important it is that we want to keep our tribal youth and our potential near their own communities. So how do we do that? If we train them, many times a technician or an engineer graduate has to go someplace else in order to use their new competencies. How do they retain that within their own communities, within their own tribal communities? And then the third one will be really looking at how do we put this all together? How do we apply these ideas in advanced manufacturing, and what are the tangible applications, and what are the resources that are out there that we can actually start doing these things, combining entrepreneurship with our cultural heritage and everything, and these new technologies in ways that are creative and useful to enhance the tribal communities that are out there. So that's what we're up to right now. So take it from there, my friend.
Ooh. So again, thank you so much to our panelists, Dr. Atsedy, Sarah, Craig, and Andrew. And again, thank you to the National Science Foundation for supporting this web series and ongoing discussions of advanced manufacturing in tribal communities. And especially thank you to the American Indian Higher Education Consortium, who serves and continues to serve many tribal communities through education and advancing self-determination. And also the many partners who have participated in this work and have allowed us to bring you this Knowledge Pack series. So join us for part 2 in our Advanced Manufacturing web series on April 5th, where we'll dig even deeper and ask the big question, what works? And what works in Indian country? Joined by guests Nick Bittner, Karen Caswelch, Giadi Malhotra, and Ryan Polk. So stay tuned for upcoming webinars and feel free to reach out with any questions. It's been an honor, and have a wonderful day, and we will reconnect soon.